Dear friends, let us discuss projectile motion. The projectile motion that we are going to discuss is a two-dimensional motion. An object is projected not vertically into space, but making an angle with the horizontal. Vertical motion is a one-dimensional case, whereas a projectile, if projected like this, will be a two-dimensional motion. Let us consider an object projected into space with an initial velocity u, making an angle theta with the horizontal. This initial velocity can be resolved into two components, u cos theta and u sin theta, where u cos theta is the horizontal component of the velocity and u sin theta is the vertical component of the velocity. The only force acting on this projected object is the force due to gravity, and hence the acceleration experienced by the body is the acceleration due to gravity. We consider a motion which is restricted to small horizontal distances and vertical height small compared to the dimensions of the earth. Very small compared to the dimensions of the earth. So, the acceleration due to gravity can be considered as always vertical, and the horizontal distances are along a horizontal plane. Now let us consider the vertical direction, motion resolved into the vertical direction. That component is u sin theta. The acceleration experienced is always vertically downwards minus g. Therefore, the equation for vertical motion, say h is equal to, that is s is equal to, the general equation is ut plus half at square. In one-dimensional case, s is equal to ut plus half at square. Here, instead of s, we are using h. Instead of u, you have u sin theta. And the t here is the time of flight, the time taken by the vertical component of the velocity to go to zero and again regain its original value, going up and coming downwards. The h in this time, the h will be equal to 0. U sin theta into t minus half, a is minus g, that is minus half g t square. You can take t as a common factor, that is u sin theta minus half gt multiplied by t. This 0 is this is equal to 0. At two situations this can happen. When t is equal to 0, this vertical displacement is 0. When at a different time t is not equal to 0, again if this factor is 0, the equation will be 0. Now you consider a t not equal to 0 case. That is, this part is equal to 0. U sin theta minus half gt is equal to 0. Therefore, t, taking this term to the right hand side, half gt is equal to u sin theta, or t is equal to 2u sin theta, 2u sin theta over g. This is the time of flight, the time taken by the object to go up and come down to the horizontal level. This t I am recording here, t is equal to 2u sin theta by g. Now let us consider the range, the distance traveled along the horizontal plane during this time interval. Since the horizontal component of the velocity is not experiencing any acceleration, it remains the same. Therefore, the horizontal distance traveled r, range r, is equal to u cos theta multiplied by time of flight. That is u cos theta multiplied by t. This substituting for t, u cos theta 2u sin theta over g. Simplifying, you get u square by g into 2 sin theta cos theta. 2 sin theta cos theta. U square divided by g multiplied by 2 sin theta cos theta. But 2 sin theta cos theta can be written as sin 2 theta. This is equal to u square over g multiplied by sin 2 theta. This is range. Range is equal to now consider a situation or examine the situation where this range becomes maximum. Suppose we vary the angle of projection, keeping the velocity, initial velocity the same. For certain angle of projection, the range will be maximum. You look at this range. Range is given by u square over g multiplied by sin 2 theta. If u is kept a constant, g is already known to be a constant in this problem. Sin 2 theta, as theta varies, sin 2 theta varies. The maximum value of sin 2 theta is, or sin function is 1. That corresponds to 2 theta is equal to 90 degrees. Or theta is equal to, that is maximum range, R max, equal to u square by g. U square by g multiplied by 1. This is maximum range. This corresponds to a theta. Theta is equal to 45 degrees. If the angle of projection is equal to 45 degrees, the projectile will have a maximum range. The height reached by the projectile, can also be found. That is, h is equal to, or we can use another formula, that is v square is equal to u square plus 2as to find the height reached. The final velocity, upward velocity, when it reaches the maximum height, is v is equal to 0. 0 is equal to u sin theta square minus 2gh. Taking this to the left hand side, we find 2gh is equal to u square sin square theta, or h is equal to u square sin square theta over 2g. Now let us consider the nature of the trajectory involved. That is, what is the shape of the trajectory? We know that it seems to be a parabola. Let us examine whether it is a parabola or not. For this, we consider two equations. One, the x-coordinate. S-coordinate is given by, x-coordinate is equal to u cos theta multiplied by time t. In this time, the vertical displacement y is equal to u sine theta in multiplied by t minus half g t square. We can eliminate t from these two equations and find a relationship between y and x. From the first equation, t is equal to x divided by u cos theta. Let us substitute that t in the second equation. We get y is equal to u sine theta multiplied by x divided by u cos theta minus half g x square over u square cos square theta. Simplifying, x tan theta minus half or g by 2u square x square by cos square theta. This relationship y is equal to some constant times x minus another constant times x square is an equation for a parabola. The trajectory of the projectile is a parabola. Thank you.